Give them advice, best practices, and the printers are really sharp, so a bit blurry. Ah, okay, that makes sense. The other printers have the same issue. They were called Right. Yeah, 43, yes. He's making photos. Yeah, he's making photos.
Hello, my name is Milos Malik, and I worked with Red Hat for several years. And I would like to introduce you to something I call the big SELinux troubleshooting chart. Please, if there are some problems with resolution of this display, it's better for you when you open the chart. I mean this one, and it's located on this address. If you want to follow me on the slides, slides are available at this address. Both the picture and the slides are available through Dropbox. I hope that nobody has something against Dropbox. Okay. So why this presentation? Why this workshop? It seems through the years that a lot of SELinux bugs have the same cause. If I take the amount of bugs which are reported each year, they can be divided into few groups, and the groups can be solved quite easily. Some of them not, and we will discuss, I hope, the majority of bugs and how to solve them, how to avoid filing bugzillas in easy cases. Basically this workshop is oriented to SELinux policy. If you, or to avoid your confusion, or if you are interested in SELinux, the parts of kernel, this workshop is not about it. This workshop is just about SELinux policy, major problems which are filed as bugzillas, and I will present you a workflow, something like a mind process, how to go through these problems and how to solve them. It also seems that SELinux documentation lacks some important info, because people still think that troubleshooting of SELinux policy problems is difficult. Yeah, some of the issues are difficult to solve, but I think that the majority of them are easy to solve, or maybe with help of our SELinux policy developers, they are solvable in a short time. What or who is the targeted audience in this case? Usually system administrators, developers, quality assurance, and also people working in global support, which means with customers. What I would like you to get from this workshop is that you will be more confident when solving SELinux issues. I hope that your troubleshooting skills will improve, and what I will present here is something which I use for several years, and I think that it's a big help even for skilled system administrators and okay. What's the structure of our workshop? Fortunately, I found out that this workshop is twice as long as I thought, so we will have more time for the discussion in the end. And before we get to the discussion, we will go through the chart. I will talk about the chart in parts, then about the whole chart. I would like you to ask questions immediately. Once you find something confusing or you want to get some answers, please ask immediately. Then I would like to show you that the chart is worthwhile or worth working with. So we will apply the flow which is described in the chart on some bugs, and yeah, I hope we will find solutions. I prepared a list of bugs which are definitely solvable, and I would like you to pick a favorite or bug of yours, something you reported either through Bugzilla or customer portal, or you just see on your computer, and we will apply the chart on the bug you propose. It is some kind of proof, or I'm confident that we will prove the chart usable. Okay, so if you, I see that a lot of you have your notebooks, so please, if you are watching the chart right now, it seems it may be confusing or too difficult, but basically the chart has several nodes, and the nodes are identified by numbers and colors, and the colors mean which kind of in which part of the process, of the troubleshooting process we are. So there are these what's that? Okay. So basically, the chart. There are some colors, like light brown. These are we are identifying the problem, then these orange ones, we are analyzing the problem, and then there are the blue ones, which mean conservative solutions. Then the red ones, these are radical solutions, and basically, yeah, we would like to go to the green one, which means that we solve the problem. And the yellow ones, we need some kind of workaround. Okay, so first part is problem identification. First, we need to find out if the problem we see is really SELinux related. It usually means there can be different kinds of problems, and SELinux problems usually manifest themselves by an AVC, an SELinux denial. Either it is a denial in the user level, or either user level, on the kernel level, and so on. For finding SELinux denials, the best tool, I think, is search. But it also means that the audit daemon must be running. If audit daemon is not running, then the AVCs end up in log files or in journal. We have to find them, or a better way is to start the audit daemon and repeat our scenario, which caused SELinux denials. Sometimes, who of you are familiar with don't audit rules? Okay, so these rules are a bit tricky because your scenario may not work and you still don't see AVCs, because there are, or maybe there are, some don't audit rules which hide it. This problem is again illustrated in the chart, and we will get to that. Other possibility, when you run X-session applications, you can of course use SE troubleshoot applet. I think that you know that. It's a small icon, usually pops up when there is an AVC. Okay, so once we are sure that the problem is SELinux related, then we can go to the next part of the troubleshooting process, which means we have to analyze the SELinux denial and find out where is the problem. If the process who caused the AVC is running in incorrect context, or if the object which was accessed has wrong context, or is there a rule missing that could, all of these causes are quite common, because a SELinux policy in comparison with, let's say, we have a program, and the program, once a developer adds a new feature to the program, a SELinux policy usually does not know about it. So once the program is executed in a way that the feature is started, there may be AVCs. This is okay, and again it is worth of reporting, because without these AVCs SELinux policy developers basically they cannot know that a program X was improved by a feature Y, XY. So there may be other problems in SELinux policy. For example, you know file context patterns. These patterns basically they match a path, a regular expression with a context. Once these patterns are wrong, you from time to time can encounter a problem like, yeah, AVC, and the AVC says there is a context, and a SELinux policy expects other context. This is also quite common, and again can be solved, and it's part of the chart. You should always ask if or why it happened, and if you see SELinux denials, do you see the consequences of some forbidden access, or do you see the root cause? It's always better to solve the root cause because the consequences, there can be many consequences, and if you try to solve consequences, you usually end up in the same situation another time when the AVC appears again, because the scenario triggered the problem again. Okay. So once we analyzed the problem, we should take into account conservative solutions. Some of you are familiar with local policy modules. Who of you knows about audit to allow or creating policy module? Okay. So please try conservative solutions first before you end up with a local policy module. Because local policy module, you can do a lot of things with local policy modules, but you can also make policy on your system more benevolent, which means you are how to say that? Basically, you are weakening your system policy instead of making a scenario work. So, what are these conservative solutions? First, there are some best practices how to do stuff. For example, running services, running daemons. In like a few years ago, people were used to run daemons just by init script. Like, I mean, /etc/initd/ for example, snmpd space and start. This makes the new process does not run in the correct context. So I advise you to follow the best practices, and in this case of services and daemons, please use the tool service or system CTL, which was introduced in RHEL 7. Oh, system D, of course. So other conservative solutions are booleans. Booleans are designed to switch on or switch off a set of rules, and there are more than 250, maybe 300 booleans right now. So a lot of possible combinations are already, I must admit, poorly documented, but are available. Other conservative solutions, they use an SEmanage tool. Who of you used at least once SEmanage? Okay, so this tool gives you some opportunities how to solve problems, and I consider SEmanage the conservative solution. So SEmanage enables you to redefine a network port, redefine file context patterns, and also allows you to make a domain which was before enforcing, now make it permissive. This kind of work, or this command allows you to make just one domain permissive, while the rest of the system remains in enforcing mode. So if you know the set enforce command, I think that you don't need to run it with 0 anymore. And also remember that each execution of set enforce 0 makes denvosh weak. Okay. Next, there are radical solutions. These radical solutions usually involve local policy modules and tools like audit to allow, which is able to generate a policy module on demand. It usually does create rules. You can also define types in a policy module, and of course you can also change roles and other stuff, which needs some advanced reading about it. I recommend denvosh's blog, and I have to repeat that again, that please consider conservative solutions first. It may happen that even the radical solutions are not usable, meaning they does not help you solve the problem. In this case, you need some workaround, and of course you should file the problem, report the problem, either through our customer portal or through Reddit Bugzilla, depending on what's your favorite kind of bug reporting. I have to say that even if I talk a lot about a SELinux policy, the fact that you see an SELinux denial does not mean that the problem is always in a SELinux policy. Sometimes the problem is in the application who triggered the SELinux denial, or sometimes is the problem in kernel. But this is out of topic for the chart right now, and I recommend contacting our developers through bug reports or on IRC channels and so on. So before, I think that the chart is explanatory, but you usually need two iterations to go before you find some kind of solution. Why 2 iterations? Because many of you know that there is a difference between enforcing and permissive mode. In permissive mode, when you imagine a running program, permissive mode means that the program is allowed to do whatever it wants. But in enforcing mode, some of those actions will be denied when the SELinux policy does not expect such behavior. It means that in both modes you get a different list of SELinux denials. It usually means that in both modes you get a different list of SELinux denials. That's why we need 2 iterations. I have to admit that not all SELinux denials that you see are really or are necessary to fix. Some of them are redundant. The program works fine even if there are additional SELinux denials. And the rest of the denials or the access which triggered the SELinux denial is necessary. In that case, that must be fixed in SELinux policy. So. Again. Do you have questions right now? Or if you have questions, please ask right now, and then we will go through a list of bugs which I prepared. Mm-hmm.
Will you be talking more about permissive domain? Or?
Yeah, I could talk because as the workshop is longer than I thought, so yeah.
Yeah, okay. That's one thing I don't know about the system.
Okay, so I have, in that case, I have an example and we can show. It's too small, right? It's better? So, I think that yesterday a guy called Etienne filed a bug which is related to prosody. My knowledge about prosody is very shallow, but I know how to find SELinux denials, and if you if you give me the scenario, I can repeat it. So I basically did what Etienne. This is the bug report. I'm sorry. So Etienne filed a bug where he speaks about HTTP versus HTTPS version of the prosody daemon has some kind of embedded HTTP server inside, and the HTTP server can serve HTTP and HTTPS requests, connections. And what he found out that there was an AVC or two AVCs on his machine, and the AVCs basically tell us that a process running in this context, prosody underscore T, wanted to bind, this is the name bind operation, so it wanted to bind to a port 5281 on TCP. Because a SELinux policy, nobody before tried that, or didn't report that, I don't know. So a SELinux policy does not have such a rule which would allow it. But we can, for example, of course we can solve this problem. This is one of the most frequent ones. And basically what we need is, here there is a nice tool, one of the most useful ones, and the tool says that this port 5281, the only SELinux label for this port is unreserved port T. If the port is the default port for the application, there should be a better labeling than just unreserved port T. Let's look at the other port which Etienne wrote about, and we see that port 5280 is called also a Jabber inter-server port T. So it seems that the HTTP connections are okay and HTTPS connections are not. So I prepared basically, what you see here is a virtual machine with rel 7.2, and basically when I try to, first you see that we have enforcing mode, and we also have, there is a tricky boolean called NIS enabled. It was before it was called allow IP bind, and this boolean is one of the mighty ones. It enables a lot of applications to bind to a lot of ports. But our scenario does not have anything to do with NIS or yellow pages. So this boolean should be off. So, and let's check the status of the service. So the service is stopped right now. When we change the configuration in that way Etienne proposed, he basically, oh, it's not visible, sorry.
Just use VI.
Sorry?
Just VI.
Yeah, okay, VI. Okay, so basically Etienne advised us to enable a module called HTTP. So we do that. Sorry. And now, let's say, first we want to see if there are any AVCs or user AVCs or SELinux errors in last, let's say, 10 minutes. So there are none. Let's start the service. The service starts, it seems, but when I run the search again, I see these two. Basically, they are the same, they just differ by the time. I see this SELinux denial. As you can see, that's the same what Etienne was reporting. And again, here is the port and the operation main line. So now we have, if you went through the chart on your own, then you would see basically two solutions. Either you can redefine the port number, or you can create a policy module. I think that we should follow the conservative solution first, which means to add the number 5281 to the definition of Jabber server port 3, which was the same port as which works basically. So, but I'm running the system in enforcing mode, and I'm not sure if I see all of these AVCs. Maybe there is some operation which is denied, but the program, because the daemon was not able to bind to that port, he gave up, and we don't see the other accesses. So now let's come to the permissive domains. So basically in RHEL 7 there are several permissive domains. These ones. So meanwhile the rest of the system is running in enforcing mode, these or processes running under this context run as if the system was in permissive mode. So they are allowed to do anything, almost anything. So now we switch the prosody domain to permissive, and we will check if there are additional AVCs which need to be solved. So, sorry. So, once the command succeeds, we will see that the prosody domain was added to the list of permissive domains. So you can see here up that these domains are defined in a SELinux policy as permissive, and these domains are defined as local customizations.
Will it stay after the reboot? Or
Yeah. They will survive reboot. So now let's repeat the scenario. So let's stop the service, and so these are the two ADCs we saw before. Let's start the service again, and there are more ADCs. Okay, so this user AVC is basically the execution of semanage permissive. We changed the policy in such a way that prosody from now on is a permissive domain, and this is basically the change. And here we started the daemon again, and because the daemon before it was running as enforcing domain, we can see here the success node and exit code -13. Now the domain is a permissive one, so we see success yes, exit code 0, And we are pretty sure right now that there are no additional AVCs which need to be solved or allowed. So, other possibility to basically this helped us to find out that which rules are needed and if the set of rules is complete, I would say. And from now on, we can either, as I said, create a policy module allowing that kind of access or redefine the port definition. So let's go for the conservative solution. So here is this is port 5280, which is allowed, and we need to add the number 5281. Basically, we do that by so we use again a SELinux command, and we instruct the policy to add another number to the port definition. So right now you can see that the Jabber interserver port T is defined as these 3 port numbers. So from now on we can the scenario should not generate any AVCs. So let's make the domain enforcing again. So again we use SELinux permissive command, but now we use -d, and -d means that we remove the prosody _t from the set of permissive domains. So after this command, the prosody domain is enforcing again. Yeah, it takes time, but it will be faster in RHEL 7.3 because a lot of optimizations were done by SELinux developers. Those just who left. Okay, so the port number is redefined, and we will rerun the scenario again. We are in enforcing mode. The prosody domain is enforcing also. So you can see, sorry. So the prosody domain is not in the list of permissive domains anymore. So we will stop the service. Let's see. There are, as you can see, there are another 2 user AVCs. One of them is we switched the prosody domain to enforcing again. And the second one is we redefined the port number. Okay, so let's start the server. It's running, and is there another AVC? It's not. So this we basically solved deficiency in a SELinux policy right now. And we used the right solution, and we just need to wait until SELinux policy developers make the port 5281 a default port in the policy. Till that time? Mm-hmm.
Okay, so let's say there's an example. some other package which also uses this port.
Mhm.
And how it's solved then, like it's my application or the new package is not Jabber server.
Mhm.
So how to solve this?
Okay, may I ask which package it is?
Oh, it's just imaginary.
Okay, so either let's see what's said in policy. Policy basically expects that the sorry.
Double O.
Yeah. So basically, SELinux policy expects that the prosody server is able to bind to port.
Port.
Sorry.
No.
Okay. So in this case, we see that there is an allow rule. If you install some other application which will use the same port, so you have to check if there are other rules which allow name bind to that port. Of course, we can use again this SE search tool is very handy, and I cannot imagine my life without it. I mean my professional life. Okay, so you can see that there is about 39 rules which allow different processes to bind to a port which is defined as Jabber interserver port T. Okay. So, but it may happen that your application is not able to bind to that port and you are not able to find a proper context for the application. In that case, you would need a local policy module.
And the port can have only one policy name or label.
It's no. As you can see here, that the port number 5280 is basically in two intervals. Like, first there is this one interval presenting just one number, and there is another interval, this. So yes, the number of the port can be from SELinux point of view visible under different names, but it brings some problems in the future. Okay. But SELinux policy defines some or these ports, so yeah, it's common.
So it's better to allow the application just use Jabber interserver port than creating new label for that port.
Yes, but these network ports, the name basically, these are you cannot define a new port in a local policy module. It's one of the constraints. You can define a port name in policy, but in local policy module you can just use it, or via SE manage you can add or remove the numbers. Yeah. That's one of the limitations. Local policy modules are mighty tool, but you cannot do everything with them. Okay. So, are there any questions? Okay. So let's go to the list. I create. Okay. Okay. So, I think that Zdeněk sits here, lately filed a bug which basically demonstrates a problem that S-tunnel, who of you know S-tunnel or use S-tunnel? Okay, so it is how to say it, a way how to secure a connection using an SSL. And the scenario which was at the beginning is that S-tunnel was not able to log any messages. It means that either nobody used it before, or used it but didn't report it, or they were running on a system without a SELinux, or maybe a SELinux in permissive mode, and they didn't bother filing the reports. So I again created a small reproducer for this, but before we get to the reproducer, you can see that the AVC again, it says that S-tunnel is not able, and here is operation search. This search operation usually means that you are trying to find a file by its name, for example, and it's not S-tunnel is not able to find a file, and in this case, before you can write to a log file, you should be able to find that log file or create it. So the bug report, basically, after I used the scenario mentioned by Zdeněk, I executed the same scenario, but after switching the S-tunnel domain to permissive, so I get other SELinux denials. And now when we see the SELinux denials, that there is something interesting, that it is always, those AVCs are always talking about var_log_t. That seems strange, because usually if there is a log file logging, basically, logging messages, then such files or such directories should have a special context. Let's see. Okay, so this tool, matchpath_con, tells us what's the expected context on directory /var/log. Let's say that we create a log file for the S-tunnel, and what should be the context of that file? And a SELinux policy or matchpath_con tells us that again it's var_log_t, but var_log_t in the sense of there are some general contexts and some specific contexts, and even more specific contexts. Like directory /var has a context var_t. When we go inside and ask for the context of var_log, we get another context. If we try, for example, what's here? Okay, for example, PCP again again has even more specific context. So we expect that the STunnel log file should have a more specific context. Again, we can use this extremely useful tool SEInfo, and we just grab for STunnel. SInfo -t, it means that it prints all defined types. And we can see here that here are some defined types, but type for a log file is not among them. So basically the bug, which was reported by Zdeněk, tells us two things. That even that we don't have a special SELinux type for log files created by STunnel, and then even if we had such a type, there would be an ABC because we were not able, or the STunnel process was not able to get to that file because the process was not able to search through var/var/log directory to find it. So now we have, again, we can go through the same scenario as before, like we can switch the STunnel to permissive. Maybe you saw that the STunnel T is in the list of permissive domains. That's of course my change, because when I reproduced the scenario, I followed the chart. I switched it to STunnel. STunnel is by default not a permissive domain. So, and now once, let's say I have a reproducer, so bear with me for a while. And okay. Okay, so I will run a test case, and this test case triggers the ADCs which are mentioned in the bug report. As you can see, here are few fails. I already added a special part to that test case which checks for the existence of the type we spoke about, and which check for the existence of allow rules. And the result of the test case should be some AVCs, and we will transform those AVCs into a local policy module. We will load it, and from that time it should work without AVCs. Okay, so let's see. So the test case basically triggered following AVCs, and now this procedure is again described in the slides. There are more slides than I will present here because we don't have enough time, and I think that those slides are for those who are interested, because the SELinux troubleshooting chart has about 40 nodes. Some of them are self-explanatory, some of them are difficult to understand, and that's why you can see a detailed description of each node in the slide. Basically, you just each node has a unique number, and in the slides you can find an appropriate slide for the node. So we have a list of SELinux denials. We create a policy module out of it. Let's see what's in the policy module. To generate a policy module, a very handy tool is audit to allow. It basically creates a TE file, which is a text file containing the definition of types and rules. And then there are some .fc files for file contexts, and it also compiles the policy into binary form. So, if we just compiled this module and loaded it into memory, the AVCs would stop appearing. Let's see. Okay, so to load a compiled policy module, there is a tool called SEModule. As you can see here, audit to allow advises us to how to do that. So the system is in enforcing the S-tunnel domain. Let's see it. S-tunnel domain. Okay, so let's remove the S-tunnel domain from the list of permissive domains. Okay, and let's run the test case again. Now, even if the policy module is not written as it should be, but the purpose of hiding AVCs or adding allow rules, it will do just fine. Okay, so okay, so we started. I think that that here you can see there are different AVCs that they are related to snort, and they are not. Let's do the. Okay, here are the last S-tunnel denials, and since that time there are just snort denials. So our test case passed. There are no additional denials. It seems to work, but there is there is still something to improve. And the improvement should be here in the local policy module, because we should define a special type for log files accessible for S-tunnel. Let's say that we will create, we will create a type called S-tunnel log T, and we will define it, I think it's this way. Maybe you wonder why there are two lines. This first line speaks about the /var/log directory, because when you create a file in a directory, it means that first you have to write to the directory, you have to be able to write to the directory, like to add an inode, and then you can create the file. If you cannot write to that directory, you cannot create a file inside. And, okay. Let's see. Yeah, I made a typo.
Semicolon.
Yeah.
Files type.
Files type. I don't
End of the line, I guess.
Files type.
No.
Yeah, no, I think that the problem is when this line, this files type,
It's a function.
I'm using a macro.
Okay,
Yeah, and when you using macros, there are no
Semicolon.
semicolons. But I think encounter unknown type, okay. This require section basically says that I would like to use definitions which are already in the policy. And what else we need? We need a type transition rule. But we will see that. No, we won't. So, is anybody of you familiar with type transition rules? Okay, basically type transition rule says that either when a process executes a file, what should be the context of the newly created process? Or when a process creates a file, what should be the context of the newly created file or newly created directory? So these type transition rules basically say what happens when a situation, when a process does something. So we will create a type transition rule which says that if if a process running under stunnel T creates a file, then the file should get an stunnel log T context. And where? In yes. So the last line basically tells us that if stunnel wants to create a file in a directory which is labeled varlog T, then the file would get a label stunnel log T.
And it's stunnel T, not stunnel exec T.
Stunnel exec T is for
the process.
no. Stunnel T is context of the process. Stunnel exec T is context of the file which is lying on the file system, and you can see basically here I can illustrate it. Let's say that stunnel we will see if stunnel is if init D or system D is able to run stunnel. It is. We can see here that init T is context for system D or init daemon, but in RHEL 7 and Fedora it is system D. So if system D starts a process which lying on the file system has this context, then the newly created process has this context. So the policy we created is we are able to compile it. It seems that some of it is syntactically correct. Now let's see if we are able to load it, because there can be other problems. Okay.
Actually, previously you installed the my policy as well at different times, so this command just replaced.
Yes, that's correct. If the important thing is that the policy definition file, I mean the .te file, it has a line, and the line says that I'm a policy module with this name and with this version. If you compile it and you leave the name the same, then new module inserted will replace the old one with the same name. So it's not necessary to remove the module and load it again, you just replace it.
And if I change the version?
It should replace it also. Okay, so we have the policy module, we loaded it, so now we can search for the... Okay, let's search for the rule we added. So STunnel. Okay, so the module we inserted, added this rule, and now let's see if it's enough. First, I would like to remove the file. So, okay, the file is not there. Okay, it does not work. So it didn't work because I forgot to add some rule. And basically the rule was, as you can see here, a best practice for writing log files is that you always append. Log files should not be writable anywhere. Like the purpose of log file is to keep the history unchanged, so you should always use append. And STunnel does it correctly, and basically we forgot to add the append permission into the policy module. So now I will add it, and so here you can see that we can create the file, we can open it, but we cannot append. These things, I mean the editing of the policy file could be, of course, done by the audit to allow. In the slides, there are two ways. Audit to allow can generate rules without using of macros or with the usage of macros. Macros have one significant benefit, is that the macro can expand to more rules, and the defined macros usually take into account several operations which are needed for accomplishing some goal. Like when creating a log file means you have to write to the directory, you should be able to create the file and other things. Okay, so can compile it. Now let's load it, and I hope that it will be all from this test case. Okay. As you can see that the checks are here green, so all the rules which are necessary are present, and also you can see that the STANL process is running, so our local policy module was successful. Of course, it can happen that there are additional ABCs, but not in this case. So all the ABCs we saw, we transformed them into rules. Then we somehow improved the rules by defining a new type for a STANL log file, and that was all necessary. It failed, but it's something. Yes, the only thing that failed is here. So we have the rules, but the file context pattern for the file is still incorrect. I will show you. So we can again use this matchpath tool, and we will ask what's the correct context for the file. It says this. So now we have a discrepancy between file context patterns and the policy, because the policy says when a log file is created by a STANL, give it this label to the file. But file context patterns will give something else, another context. So let's use again SELinux to improve the situation, or maybe I can show you what happens if we don't do it. So I will just touch while log STANL. Basically the test case cleans up after itself. That's why we don't see the STANL. But I can of course change it. So I will remove. Okay. Let's run it again. So now the test case does not clean up on itself. So there will be the STANL log file on the file system, and we will see that the file has a different label, and different label than what policy thinks about it. And we will run a restore con, which is again one of the most useful tools to correcting contexts on file system. And basically the tool will screw up. Okay, so the file was created correctly, created with a correct context, as you can see, STANL log 2. But once I start restore con, I feel that recursive is not necessary right now. So you can see that restore con changes context of the file, but to worse. So if I run the test case again, we will see again SELinux denials. So the solution, again, a conservative one, is to change or to define a context for the path. So we do that by, again, a SEManage tool. Okay, so this command will change the file context patterns database, and it will add a connection between stunnel log_t context and this path. From now on, the matchpath con will say that the right context for our file is this. So this is the situation we wanted. Now we can run restore con again, and it changes the context to the more specific one, which is correct. Okay.
Just one question. Is it better to put the file context in model? So when we maybe remove the model, so the file context could be...
Yeah, it is, of course, it is possible. You can see that when I executed audit to allow, it basically created several files, this for one. And here the my policy FC means file context, and if you want the context to be part of the module, you edit this file and you basically place the definition. So yeah, you can do that by editing this FC file. We are, or do you have other questions? You can basically ask anything SELinux related, and I hope I can answer.
Do you have some recommendation for creating possibly SELinux related bugs, like what to put to the description, what information it should contain? Of course, some ABC denial message, probably SELinux policy version, but anything else?
Yeah, definitely. I usually recommend put there the SELinux policy package version, like which version of SELinux policy was installed. Sometimes the version of kernel is also handy. And when don't use grep for finding ADCs, please use allsearch, because when you use grep, it does not catch all the lines. I will show you.
The usual doesn't source this code.
Yes. Sorry. So we are looking for, for example, type ABC and type syscall lines, and there are a lot of them. Sorry, that's so. So this is the information which the SELinux policy developer needs to see is both these lines. But when you use allsearch, it will provide even more information. For example, I can show you what's the difference. Let's see if there are. Okay, no. Okay, so the difference between just grabbing the audit file is that you see some cryptic, I would say cryptic hashes like this, for example. Yeah. When you use OSearch, it has a feature or a parameter which is able to interpret those hashes, and the output looks in a different way. So now the hashes, the cryptic hashes are away, and you can see that here are like path, complete path, and here also. Yes. So please use OSearch. SELinux policy version. If you gather all AVCs in enforcing mode, a SELinux policy developer will most likely ask you for a list of AVCs gathered in permissive mode. So if you provide both lists, you save one round trip time. And when filing bug or customer case, if you describe the scenario, what happened, it's even more informative for the developer, and again for me, because it will most likely end up in my queue. Okay. Mm-hmm.
You mentioned that module can contain file context definitions, so that I don't have to label the files or folders manually using the SEManage tool.
Mm-hmm.
Using SEManage,
Mm-hmm.
you can use regular expression.
Yes.
Like all download folders in all home folders for various users.
Mm-hmm.
So you use regular expression. I was able to get absolute path working as a file context definition using the gen context function in a module. It worked. I was able to use SE module with the regular expression. It worked. But when I use the same regular expression in the same module instead of the absolute path, it stopped working. Is there some gotcha using regular expressions in SELinux?
I think that the usual problem is here, this specification. I mean that did you use this dot asterisk?
Yeah, it looks exactly the same.
Okay, so maybe I will after the workshop I will go and we will see the problem.
Okay, so no generic advice.
No.
Okay.
Even for example, if you specify these tokens like twice in the pattern, then it could be a problem when interpreting it and so on.
Okay. Thank you.
Yeah, usually when I try to understand the ABCs, I would like to know where to look for more explanation, like what is the type, like what are similar types, if there are any booleans, and not only just one line, but one paragraph of explanation what it does, and so on. Is there any landing page how to move forward with this ABC?
Yeah, that was the poor SELinux documentation I was talking about. Yes, these booleans are documented, but there are.
That's online.
Yeah, that's the one line. Unfortunately, there are HTML pages, part of a SELinux policy doc package, and if you don't find the description, the detailed description in those HTML files, I think that we don't have a better
I think
documentation.
that audit to why sometimes give an advice to enable boolean.
Yes, yes. But if you go through the chart, you will see that the recommendations given by audit to allow are not always the best ones.
Yes. So is there any other helper for troubleshoot?
Yeah, SELinux, basically this, let's see what's... SELinux is a tool which goes through the reported SELinux denials. There is a database, and it tries to interpret what happened and gives you some advice. And you also, but you asked about the booleans, and I'm afraid the SELinux documentation lacks a lot of documentation. Yeah, sorry, we are running out of time. If you have other questions, please come to me. We will talk personally.
Jo, musím bez do té šály, co se ptali.
Yeah, those who ask. So, here. Okay. And I think that here was a question.
Když jsme to dělat kometa, ne? Kometa.
Thank you.
Musím skočit pro kafe, člověče, no ty jdeš někam na kafe?
Většina napadá z toho.
Jo, za 2 minuty se spát.
Jo, v pohodě, jak jsme si
Jo, tak jenom jednoduchou věc, jestli tam budeme potkat někdy mimo defron.
je tam nepoběž.
Třeba potkáváte se s vývojářem přímo.
Jo,
Takže podle mě kontakt mezi náma a těma druhýma 2 skupinama chybí. Asi možná my to nepotřebujeme tak často.
Ne, já s tím souhlasím, já jako já vždycky, já třeba pamatuju občas si sám ale tohle prostě, to je jenom čas od času,
Je ten člověk vedle Simona. Říkal, že to jsou ti vývojáři, kteří odešli.
Možná když mi ukážeš fotku, tak řeknu.
Dobrý.
Jo, světí. Můžeme
Nevím, jestli budeš potřebovat na prezentování.
No, asi ne, to bych
Ty jsou tady, ale jako jestli, já nevím, na tom něco je nahrané, ale nevím.
to mě tam se mělo být.
Jo, tak potom v tom případě...
To zvládám relativně na základní úrovni.
Jo.